All right. Good morning, everyone. So you had a very nice coffee. The belly's full, so we're ready for another session, I assume. Thanks again for making it to this beautiful event. I'm Pierre Padilla, I'm CEO of Enable. We are Innovation Investment Advisory, meaning that whenever you talk to me, please bear in mind I'm not an engineer, so you have to explain things to me like if I were a 5-year-old. But that said, very much active in the battery landscape and very excited to animate that session. That very session is really about stepping out of VERSAPRINT and looking a little bit more broadly at complementary projects for similar, with similar angles, and to explore a little bit future research, collaboration opportunities, what are bottlenecks, how we can actually overcome this. So feel free to interrupt, feel free to ask questions. Let's keep it interactive. You know, we're not here to just, throw a presentation and go to the next. And on that note, I would like to first extend a big thank you to our colleagues who organized this event. I think that Lomartov, CEA, it's very much appreciated. Thanks for welcoming us. And I must say that we are very lucky to be today in Grenoble, which is actually a nest of innovation and of the French tech. And I think that we're very lucky to be hosted by CEA today. And thank you very much, Lomartov colleagues, for again delivering on this kind of event, which I have found over the years quite successful and very much appreciated. So now I'm done with the monologue. Let's go to some more interesting people. And I would like to start first with the BATS project represented by Stephane Chevillard from IFP Energie Nouvelles. Thank you, Stephane. So just to give you the bio of Stephane, which I now know per heart, well, almost. So you completed your PhD in combustion. I think you're coming from the other side of the border, right? And combustion modeling in particular in 2013. Then you spent 8 years working on the internal combustion engine. And after that, you had the epiphany. So 2021, you shifted back to the right side of the force. And you transitioned to electrochemistry. Since then, you've been working on battery system modeling with an emphasis on nominal and abnormal behavior at the cell level, as well as thermal management at the pack level. So I'm sure you enjoyed already the first part of the presentation. But now it's your turn. Well, up to you if you want to stand or the mic.
So, and pour les slides. Non, ça c'est long. Okay. Okay, thank you. Thank you for the kind introduction. So, as you may understand with this introduction, I'm not the coordinator of the BATS project, but I'm from IFP Energie Nouvelles, and I'm responsible of the work performed by IFP in the framework of BATS project, which mainly focus on thermal management system and optimization. But today I will try to introduce you the larger framework of the BATS project. What are the objectives and what are some of the interesting results? So in a nutshell, so BATS project is so first BATS stands for Safe Efficient Battery System based on advanced cell technology. It's part of the Horizon Europe call. I think it's the same as VERSAPRINT, about next generation technology of high performance and safe by design system for transport and mobile application. The coordination is performed by CDTech, and it involves 10 partners all around Europe, Europe, as you can see on the map. So the overall concept is to design and manufacture a cell-to-pack concept based on a battery system that explicitly covers a safety aspect, and which will be valid for several types of transport application. So the approach and the concept of the BATS project is to have a modular brick which can be used as a reference to build a higher capacity and or voltage system. So this brick come from the macro cell concept from MIBA battery system, and we aim to upgrade these macro cells to a more complex cell-to-pack system. So The battery system is based on the cylindrical cell from Gen 3B technologies. The targeted end use cases are mainly three types. So first, we have the e-vessel, the excavator, electrical excavator, and at the end of life of the battery pack, we dismantle the module and use it for volt stations. So the overall scope of the project is to build a proof of concept for a 5 to 10 kilowatt hour battery system with less of 400 volts. But this pack size will only be a demonstrator for the final product, which aims to target higher energy and higher voltage, even up to 800 volts for buses or trucks applications. So let me now introduce the main objective of the BATS project and how we achieve them. First objective was to design the battery system so that we can use it in various applications. So we use 1D simulation to extract the temperature, the output values, so such as temperature, voltage, current, etc., and to see how the battery pack could match the expectation from the various use cases. So this objective has been achieved. And the second objective was to develop the actual pack, cell-to-pack concept, in order to reach the electrical, thermal, and mechanical performances. With keeping in mind that we have to build a safe-by-design product. So the indicator we look for was to fulfill the safe-by-design concept we decided. Then we work on the optimization of the electrical, mechanical, and thermal parts of the battery system. Each of these criteria, so electrical, mechanical, and thermal properties, have been optimized in dedicated work packages, and the work package leader ensure the reliability of this of each of these function of the battery system. And the final objective was to reduce the battery system cost, and we managed to the target was to reach 2 to 5% cost reduction. So all of all of these objectives have been accomplished now, and the cost assessment is still ongoing. So third objective was to validate our approach concerning the safety. So we used the test to validate that our battery system was able to answer some specifications. So our target was to reach the UCAR hazard level of 5 for fire test and lower than 5 for other tests. So here, the final battery system validation is need to be complete. So we are actually building the actual battery system, and the test will be performed in the last quarter of this year. Fourth objective was to improve the assemblability and disassemblability of the battery system. So to do that, we optimize the manufacturing key processes and develop assessment tool for recycling and second life. So we achieved this allow us to look at the cost reduction, and we are with the objective of being twice cheaper for the macro cell at the macro cell scale. And concerning the second life assessment and recycling assessment, this now we have fixed all the actual components, and we are currently doing the LCC analysis. So this task is still ongoing. Finally, on the objective, the fifth objective was to perform the LCA and LCC assessment. So, as I mentioned, these tasks are still ongoing. And as for every European project, the last objective is to communicate and disseminate our results. So here we build a dissemination and communication plan and key exploitation results. And we have to mention that now we have fixed all the technical bricks of our system, and we are currently being prolific in showcasing our results and writing publications. So let me talk a little bit about the use cases. So here you have a big chart with all the data that our battery pack, our battery system need to achieve, and you can see that there is various conditions. So the energy of the battery system varies in function of the application. So the main word here is that the battery systems need to be modular. And we will see the result and how we built this modularity in the next slides. Sorry. So in the process, we achieve some very interesting results regarding electrical, mechanical, and thermal components, and I will showcase now example of such outputs of the project. So first example is the work on the module management system. BATS project has been the opportunity of building a wireless BMS with a low consumption. We also work on the power switch. We built a silicon carbon based power switch, which allow faster shutdown of the battery system, and which allow to protect the power components from irreversible damages. We also work on the DC-DC converter, building silicon carbon based DC-DC converter. You can see here the main properties of this DC converter, and this is there is a patent ongoing on this topic. We also build a downscale module. So with this downscale module, our objective was to evaluate the performance of the system, but it was also a big opportunity to validate the model we use for the development. I did not mention, but a lot of this optimization has been performed using a numerical tool, and it's such a methodology requires validations. So we use the data we get from this downscale module to validate all the numerical approaches. So about the modularity, so the concept is to have here the macro cell, which is an assembly of cylindrical cell. And from this macro cell, we can plug together several number of these macro cells to build a macro module. And so for the final product, we can stack various number of this macro module to reach all the properties required for the targeted application. For example, for the marine application, there is 16 macro modules which are put together. And for the off-road application, so the excavator is only 4 macro modules. And all of these macro modules could be easily dismantled to get to the module level and to be integrated in the Volt station at the end of life. So example of modularity and easy assemblability and disassemblability of the system. So we use the flex cooler from MIBA battery system. And you can see on this picture how it's easy to integrate in a cylindrical cell pack. And we also wanted to ensure that this flex cooler was able to manage thermal runaway. So some tests, have been performed with this flex cooler on a battery pack with slow heating and rapid heating, and we see in for both initiation scenario no thermal propagation occurs in the pack, or at least very limited propagation. So that's what the result I wanted to showcase with you today. There is many more results in the battery BATS project regarding the remote battery management system, the venting management, the thermal runaway, the recycling and second life. So we can discuss all these results. You can feel free to reach me during the day to discuss every point of this. And I want to advertise that we have a closure workshop which will be taking place in San Sebastian. The final date will still need to be announced, but it will be in October of 2026. And every stakeholder, researcher, or related project are welcome to this meeting. So thank you for your attention, and yeah, do not hesitate to reach me.
Thank you very much, Stephane. Any question so far, or any comments? I see in the back.
Hello, thank you very much. I just wanted to add, so it's not a question, it's just to add, so that BATS and some of the other projects here are part of this cluster, and now you understand why. So the goal is to create a toolkit of components and of innovative components at system level, and this is why we join effort, because we all target the same objectives in a different way, with different strategies, but in the end, you can put all the technological development from the 5 projects, and you have a toolkit from which you can pick for a specific application or a specific objective. So this is why we join effort.
Thank you.
Thank you very much. I leave that one to you. If no add-on, then thanks a lot, Stephane. Please sit in the front somewhere, because I want to capture you for the second part of the session. All right. And our next speaker, Bruno Rodrigues from AVESTA. So Bruno, if you may join me on stage. And Bruno, you have 15 years in production and emerging technologies across different fields. I was very surprised to see that we have some in common. And quite experienced in international, national funded EU projects. And you hold a degree in material engineering from University of Porto, as well as training in team management quality. And your thing is really excellence in engineering, which I definitely appreciate across industry, aerospace, maritime, ocean domains. And lately you joined AVESTA, actually, as European project manager and very much involved then in the sector. The floor is yours.
First of all, I would like to thank you for the invitation to be present here, and I'm very happy and glad to see VERSAPRINT reaching their goal, and I hope also to do the same with Extended in a couple of months ahead. And my approach in this point was a little bit different from what we see. I'm going to focus on what Lisa Lu also introduced right now, that is what the synergy brings to this, and no one can develop a project by itself, because we see nowadays battery systems are getting more complex, trickier, and very difficult to handle by only one specialist. So we need to bring what in Europe realize the most, or it's the best expertise to bring this. And another topic is we can see that the market, we are losing to the competition, and we need to put some time to pressure to deliver good products and things that are reliable to Europe. And the other thing is how we can cover this TRL 5, 6, and then to give the, let's say, the big jump ahead to start going to the market. Because it looks like it's easier, but we already saw today that there are always some points that we need to understand how it's going to scale up, how it's going to evolve, and that's a point that all of us and the battery community is concerned, and we need to do this jump for the future. We can see here, tackling the part of being a very complex system, is we almost have in a battery pack, let's say, a micro world of components, of things happening there. It's not only the cell, it's not only the module, it's not only how we can close, or we can call it a pack. It's a very complex system that involves several areas of expertise, not only electrochemical, not only chemical, not only mechanical, but altogether, we need to come in projects, in a community, to try to tackle this and to deliver what is expected from the industrial area. And where this happen, now jumping to my own perspective and to my own reality, that is Extended. In Extended, you can see here a little bit of what was happening from the cell to the module to the pack level. This was the main challenge that we have, not to develop cells. This was not the goal of this, or the goal of this call, but to apply this and to make it the next generation battery pack system that can answer several parts. In our case, for example, and once again, like BATS and like the other examples, we are trying to tackle 4 use cases. That's the automotive, the aeronautics, the heavy duty, and also the stationary approach. And for this, you can see here, this is already our final design and final approach. And in here, I try to present what we need to do and to bring us a synergy of teams. Like, for example, CEA is with us developing a connection in the wireless BMS with also a new wave of sensors that are not like CEA that are printing directly in the cells, but also developing a very thin, paper thin sensors that can allow us to monitor from humidity to pressure to a lot of other things. And you can see here that it's also connected with this BMS and like say a custom-made solution for our project for these BMS slaves. Then we are also tackling a new approach for cooling, because we did a part again about the thermal runaway, how to tackle it, how to keep it cool, the battery pack. And for this, we are coming to a solution that is a mix or a hybrid between a 3D printing polymer, Ultem, together with also a very complex machined aluminum part. And even with this, we are complying with one of the objectives, that it was to bring the weight down to an acceptable level regarding the market. We are also trying to do, and to keep, my apologies that now I'm seeing that the modular design is being covered by the picture, that we are also trying to create a modular approach and something that it's feasible, replaceable, and also connected with sustainability by design. Also together with LCA studies to try to understand where are the key points to change. And this is also linked with one of our previous tasks that was design for excellence, to try to keep everything lean and to try to keep everything focused on the approach to the design. And now entering why European synergies matter for extended in our particular case, but also for the other projects. That is, we need to bring the expertise from all over Europe. Here we have some examples of a lot of partners that are experts in their area. And for this, I give here only a small example of how things can go. We designed the module. We need to validate it through simulation. And then in the end, we did it in the safety tests. And this was performed by several partners. We started design with BMZ together with us, AVESTA, and all partners. Then simulation was performed between Ikerlen, Mondragon in this part. And then the tests were done in THI in Ingolstadt in Germany. Without this synergy, it's not possible to go forward. And we need to come together. And not advancing, but for the discussion, it's something that we need to understand how we can bring even bigger challenges together to this community. And what we learn here, bringing again, we try to create energy density of 173 watt-hour kilogram. We achieved the 50% weight reduction in what was our baseline in the beginning of in the proposal. And we also achieve a 40% thermal safety regarding to this final design that we are presenting. And now coming to the part that I'm trying to come here, it's about also the Ingenious. Why we have created Ingenious? We are 5 projects under the same call that we are developing next generation battery packs, but all with different focus and different approaches and almost complementary. If you bring all these 5 projects, you would probably achieve what we can say a perfect battery pack for the future, even in a TRL 5.6. And it's interesting, and like Lisa Lu referred, we are trying to take advantage of this clustering, not only to be something that you put a check box on the proposal because it's mandatory and it's something on the requirements for the European Commission, but to bring value not only for our projects, but also for the battery community, that we can contribute to development in the future for this. And like I'm writing in the bottom, it's something that we are trying to transfer or the results that are transferable, because then we also have here a bottleneck that it's called intellectual property that sometimes appears more than than frequently, putting some barriers on the transfer of innovation. But this is the beginning. We can talk about the cluster, that it's bringing VERSAPRINT, Extended, Tempest, NextBot, and BATS that are part of Ingenious Cluster, and we are participating in several events to try to, or we are even creating our own events under each one of the projects to discuss specific topics from safety, design. But we are also contributing or talking together with BEP and to Zero and trying to bring these results to be aligned with their strategy and their policy with the European Commission. But another thing that it's also interesting, and we learned this not a long time ago, for example, in Battery Innovation Days, we had an event for clusters, that is, we cannot lose the knowledge that it's developed under each cluster, because it's specific knowledge. But if we bring all the clusters together, in this point in the discussion and the development, it's even more interesting, because there are a lot of other areas that probably we are not even aware, because we are focused, for example, in next generation battery packs. But some of the developments here can be applied in other cluster that is developing even something for another area of not automotive or not aeronautics, but it can be interesting to go there. So I think it's one of the biggest synergies that we can have. It's not only communicating between projects, but also extend this to the research community, transversal research community in Europe. And I think if all the synergy and all the projects come together and we can even contribute with a little point of knowledge to go forward and to develop new products, I think we can achieve an electrifying future. I do not put here, I forgot, unfortunately, to put here also our close workshop will be also in October, not colliding with ones from BATS, but I will also like to invite you and to pay attention to the social media. And if you want to go to our website, our news are there, and it will happen in the beginning of October. And we will be very happy to have your presence there. So thank you so much.
Obrigado. Any question or comment? I keep you on stage, Bruno? And if not, can I ask you all to raise your hand? Just 2 seconds, please. Everyone in the room. I'm just checking if you're alive still. So that's good. Thank you. Stephane, can I please ask you to join the panel? I have a few questions for you guys, but you know that already. Please take a seat. You pick the one, you will be judged on the seat that you pick. Yes. All right. Thank you very much to the both of you for your presentations. Super interesting. Thanks for burning so many cells as well. I think that proves very useful. But it drives me to a key point that you both highlighted. And I heard you laugh when you saw the valley of death on screen. Valley of death, we have different valley of death, right? Then my question is here, we end around TRL 5, 6 in those projects. That's beautiful, that's already great. What about the key bottlenecks? What about the key gaps to actually move further towards, demonstration, deployment, and so on? Who wants to start? I give you a head start.
I can try to. Yeah. So for me, at such TRL, so T5 and 6, the technical parts of the system are already demonstrated. We can see from VERSAPRINT project, from BATS or every project in the call, the final product achieved the goal, the technical goal. So I think to reach the industrial world, the key point is not in the technical part. So it's, I think, more in the commercial way. So how we can afford this technology. So the cost is a key point, but if we are realistic, it's really hard to be cost effective with innovative battery system, especially if we compare with thermal system. So I think it needs to be a consciousness of the industrials to be part of a change, a required change, for a change for ecological reasons, but also maybe for sovereignty reasons. So we need to have a will for the industrial, or if not, it will be by the government to impose the rules to the industrial, to bend their arms, to force them into this change. So yeah, for me, we have to look this way.
So basically, the end user has to pay for it, in a long story short. That's a bit the message.
Yeah, and we have to still work to be cost effective. I'm not saying that everything is done and we give up the optimization, but yeah, change as a cost, it has to be paid by maybe by the end user, or more maybe by the industrial, by reducing their margin and say, okay, we are not losing money, but not winning as many money as we could, but we are part of the change, and yeah, that's my point of view.
And when you say cost, I mean, it's the overall system cost that we're talking about. But what do you have in mind? What are the key bottlenecks there? I mean, are we speaking of the strategic raw materials that we find in there? Are we speaking of, essentially the scalability of the system, manufacturing processes? What do you mean there?
Yeah, for me, cost, cost maybe at the very the smallest scale, the cell is the most costly thing, and especially if we want to build this cell in Europe, this has a cost compared to Chinese product, and we have to pay this cost to be sovereign in our energy consumption.
Cost of sovereignty,
Yeah.
cost of independence. Yeah. Thank you very much, Stephane. Bruno, what do you think? Do you agree with Stephane on the main bottlenecks? Is it something that you relate to?
Yes, I agree that probably the main bottlenecks are the cost and scalability, because probably this is not only my experience from the battery field, but from a long time ago. It's always related with scalability and the cost, because we can produce something that it's even validated at a scale level, but then the problem is how to put this in a level that it's interesting to industry and keeping the costs low. And we saw here in the presentation for aeronautics, that's a question. We need to understand how to adjust what is working and what is probably scientifically overcome, but it's still an issue for industry to try to adapt it, not only by the safety, this is always a problem, but I can give you a very quick example from the past, a long time ago and not battery related. That is, we developed a very interesting product in titanium for automotive. It was the top tier killer for turbochargers. We achieved the technical solution. It was very interesting, but then we stumped with all the problems that it was 5 times more expensive than the usual product. So who is willing to buy that? Top tier brands or and then also the materials. Even if you acquire the materials in large quantities, it should still be very expensive to produce. Not the titanium part. Titanium, we always knew that it was part of the cost, but all the materials involved to produce that. And I think it's more or less the same in what is happening in batteries. We can develop, but for example, we have the 3D printed sensors in our case. My question is, it's working very well, it's proof, but how we can scale it up to bring to industry and to produce not only 30 or 50, but to produce thousands. That's something that probably we need to start thinking, and I fully understand in TRL 5.6 it's difficult to put this ahead of our thoughts, but it's probably, and I can answer this later, how we can tackle this for the future.
I would be very interested to hear that, because I'm thinking a bit of the Northvolt story or the ACC difficulties. I'm passing over a number of others. I think that we've seen plenty over the past 3-4 years. But then I think that this is clear. But then what you guys mentioned is that at some point we need to bear the cost. But is it the only thing that an OEM will expect, that we have the right price? I'm just thinking of a world where public authorities will actually provide, like we saw in other countries around the world, big packages of money to say, okay, we low down the cost, whether it is legal or not. We low down the cost of the product, and you will flood the market. Is it just what we need, or do you see other parameters, to convince OEM to take up our systems?
Sorry to take. I think probably in some point it's to prove the reliability compared to the existing solutions. For example, I understand in aeronautics, for you to put something in an airplane, it will take years to comply with regulations and to match the regulations that are existing. So if things are reliable and it's proof ready, I think industry will take it blindly. If we still have to prove that it's reliable and it won't take fire in a plane and 300 people will die for this, or even in a boat that you are stuck in the middle of the Atlantic Ocean, it is an issue. And that is a point that probably working together with the European Commission to try to create even standards. And one point in our projects that it was interesting to complete this is we were invited by GRC.
To the Joint Research Center, yeah.
And they are also trying to push and to adapt regulations to match what we are developing. So it is they try to understand what we were developing and to try to understand how regulations are, and probably regulations also play a big role, because normally we have right now to adapt to regulations that are for old technologies or not updated technologies.
And with new ones coming
legacy.
up, right? We have the Gen 5,
yes.
At the door. And Stephane, you wanted to rebound on the OEM adoption?
Yeah, what you said make me think that we have to work also with the European Union and the governments to make them understand what we are doing. And I found I'm not maybe the most expert in the relationship between a researcher and government and the Europe Commission, but from my point of view, sometimes it's kind of hard to make them understand simple things.
Why? Why is that hard? Because no relevant profiles?
Because they have their ideas. For example, in the past project, we faced the failure of the European cell provider. And we have to make them understand that there is no backup option in Europe. And we have been stuck for months discussing with them to make them understand that there is no other option available. So it's an example, but if we want to make them understand that our solution is good and they have to invest money to help bridging the gap between TRL6 and industrialization, it needs communication efforts of communication from our part to make them understand the final goal and the benefit of our approaches.
I will get back to this to challenge both of you guys on this, but just to close on the obstacles. We didn't mention equipment there, so we speak of manufacturability, but it's kind of broad concepts, right? What about specific equipment? Do you see any gaps or any challenge there? I mean, especially considering that a lot of the equipment we see in battery manufacturing lines today are maybe out of EU sourced. Is there any point there that you see where we can that we're challenged in Europe?
I think it's probably one point that European projects didn't focus. It's on development of equipment to produce battery packs or to produce cells. Nowadays we rely still on Asia, let's put it like this.
Not mentioning any country in particular.
to get equipment, because there are, or at least that I'm aware, no one that is specialized in specific equipment aside from welding, because that it's
so it's more the specialized equipment. It's not so much the line integrations part.
No, I think line integration we have, and I think the example in Europe from all the even in the RTOs and all things, that the expertise is there. The problem is some specific equipments, and mainly I'm talking about as a cell producer. It's the equipment to produce that. It's difficult to have it here, or you have to produce from the scratch, and it takes time, and we are doing that. But if you want to have something that it's readily available in 1 year or 2 years, you have to knock on the guys that are already produced them.
Indeed. Reaction, Stephane?
Yeah, one of the bottlenecks also could be the raw materials. We do not have all the materials in Europe. So
which one in particular? So you're thinking of cobalt, nickel?
Yeah, cobalt, nickel, etc. So that's why and it's a good point that Europe put a really big accent on recyclability of the cells. This is a way to import this on our countries, the materials. So at least this bottleneck is understand as is tackled, but it takes time. I think it's very difficult for the industry dedicated to recyclability to get money now, because not so much cells are in the market and even less available for recyclability. So yeah, and the technology is not also fixed. So a lot of challenges for them, but yeah, I think this is a point that is addressed, and it's not easy one.
Yeah, there is a momentum issue on the availability of end-of-life stock. I was wondering, because this is a hot topic in a way, but we see that there are many projects out there in the market, from Orano to battery, to so many players that we have across all countries. One thing I was wondering is we've been pouring already quite a lot of cash in battery recycling ahead of the availability of critical mass, right? Do you have the impression that in Europe we are over-investing in some parts, under-investing in others? Is there anything that you think, hey guys, we really need to consider that specific kind of topic or item or segment or technology as a key investment for the European Union, member states? Anything in particular comes to mind? It's a $1 million question here.
Yeah, from what I see, and when I see the difficulty of cell manufacturer to reach the markets, maybe a bigger effort should be put to help them, because there is a failure example, many failure example, unfortunately. So maybe this is the point I can see, but I have not the figure in mind. So yeah.
Yeah, that's an interesting point. So still this scaling up and manufacturability aspect more than.
I don't know if this topic is going to be solved in this next wave of or the next framework.
Well, we fix it today, it's okay.
Of the European Commission, because I think one point that would help it was to create bigger projects that involve a lot more players, and that can cover not only us, because I think it's a problem not from research. I understand the research point of view, but for industries, you focus in a very small dot of the problem. And then you need to connect all the dots to have the bigger solution. And this is, if we start talking about projects, if any project endures between 3 to 4 years, when you reach the entire system, it's already past more than 16 years.
Yeah. KTL and BYD are way ahead.
And probably it should be interesting to create something like the innovation funds, but in a bigger approach to bring the bigger players in Europe to come together and to develop. I know that then, like I was telling, intellectual property will play a big role in this. There's always this problem between everything, but it is a way to tackle. It's to bring everyone to the same table to discuss and to try to put Europe developing this.
In short, you guys still believe that we can have our gigafactories up and running as long as we help them bridge that valley of death, so to speak.
I think so.
All right. Maybe one question, because indeed in some countries now we see that the money was poured in one champion, so there was a race, and at some point the government says, okay, those are the two winners, here's the check. I'm caricaturing a lot here. But what I like in what you say, Bruno, is that the European way is a bit more collaborative. And I think that the cluster is a quite interesting approach. And the Commission has been promoting a lot this clustering thing lately. How do you see the collaboration next? Because communication dissemination is one way. But how about, I don't know, shared equipment, shared infrastructure? You do my mechanical testing, I do your thermal testing. I have no idea, but what is your impression? How can we push a bit the synergies between those projects and maybe beyond those projects?
Yeah, from what I think is this connection have to be made person to person. So, for example, like today we are discussing, showing each other works, and I see an interesting methodology which is applied, and I have my own, and we can confront our ideas. And I think it's more a person-related topic. It's quite hard to I think manage a large amount of people and force them to work together. I think we will create emulation by showing our work and showcasing what we've done. And we work in the EU-INGENIOUS cluster. We work on this very similar thematic, and we use different methodology tools, etc. So now it's with paper communication, etc. It will be the opportunity to exchange our way of working.
Okay, but more ad hoc style than in your mind.
Yeah, I think that's it. Right?
That's the way. Bruno, do you agree?
I would still persist with the cluster, but in a different approach. And I think what you are saying, it's interesting, because probably the clusters can share some of their outcomes. I can give you an example, not from this project, but from another cluster. that I'm leading, that is, we are going to put, and as Lisa Lu said, we are going to produce a toolkit. This is going to be the result of this cluster to help the community.
Yeah.
In another one, we are going to put, it's mainly related with digitalization of testings. And what we aim to do is to put out a white paper stating all the state of the art that we developed, that it's not also, again, interfering with IP. But one question that concerns all of the clusters, and it was something discussed in the cluster community, let's call it, is normally this ends with the last project that it's inside the cluster. And then you lose all the knowledge, you lose all the information.
And the collaboration kind of fades away.
Fades away, and you spend the money, or European Commission spend the money, and everything is lost, let's say. One way is to try to create a legacy and to keep this running and to push these final results, like you said. For example, it could be an equipment, and it can only it can be available for the battery, but probably other type of call in, let's say, aerospace, in space industry, in other topic, it's interested in using that. And if you then start matching the points, you will reach say, okay, they can also benefit with this, and this is only not focus. So it could create bigger and broader approaches, and probably speed up some developments in some areas, because I think we are very tight connected in our box, or very, how can I say, we are very stuck in our box, and probably there is other areas of development that can also help us. And this is an area, for example, like CEA and all the other things can benefit, because they are reaching to such a broader view that probably in industry it don't happen. And also probably in universities you are also very focused in your research, and not also in what is happening in the other department or in the other area of expertise.
Yeah, so open up the silos, basically. Yes. Indeed. Good point. Please, Lisa Lu. I'm looking around to see if I can steal a microphone. Oh, thank you, Michaela.
I just wanted to add, now that we talk about synergies and so on, and I think another important point would be standardization, as this is one of the challenge that we see and we discuss often with the cluster and with the partners, is that we all build different things, we all use different strategies, different architectures, different applications, and so on. And in the end, then it makes it difficult to move forward, as we all go to different directions. So I think Europe is trying, and the governments, and they are trying to standardize and help us standardize, but this is coming late. I mean, in Asia and in the concurrent, they go together to one direction, and we go to many directions, and we innovate a lot, but in different directions. So I think that's a challenge, and I think if we manage to work in a similar direction, at least not the same, but a similar, that maybe we can go a bit faster there. For example, for the recycling companies, then it's difficult for them to go faster, as they can recycle one type of chemistry or one type of architecture, but then we have so many different that they struggle to have processes for the different architectures and so on. Yeah, that was just
a bit of an EU syndrome somehow. And is it something that you guys have already built in the cluster, for example? Input to Sensenelec, having maybe a task force around the topic?
So not yet, but that would be one goal that we would have. And there are other clusters also. There is another one that is called Collabat, if you're interested. There is also targeting system-level development, battery systems, and the goal is that we share our results with them as well. And I know that there are some other clusters that do this, and they standardize their tests, for example. So we did this too late for us, but we want to try to work on this afterwards and see what were the similarities and the differences. But I know that there are other clusters that do this from the beginning, now that we know. So yes, they try to, different projects try to have the same, for example, safety test plan. So they all do the same tests, and that's already really interesting.
Yeah, creates a generalization potential across the field. Super relevant. Thank Thanks a lot, Isarou. Reaction on
If I can add one thing
select
to
topic?
this standardization, that it's an experience with BMS, is I'm doing the standardization approach for another project, and what I found is easily we have 45 standards across from ISO to IEE, and it also starts to be a nightmare to understand where do we fit with new products, and then you have the time for, if you want to develop a new standard, that's another thing that we need to understand. You need to do it local, that it's another strange thing, and then it grows to an ISO, but you need to start local, and if your country is slow, or if you don't have the right tools in your country, it will take even longer time. That's another thing that probably European Commission can speed up and try to understand how to uniformize this approach to standardization.
Mm-hmm. Yeah. Stephane, any strong point on the topic? It's a bit of a specific one, right?
Yeah.
The standardization part. I mean, and you mentioned ISO, but I assume that okay, we have Sentinel in Europe, but whenever we move to ISO, then we also have to face the Chinese colleagues as well on the other side of the table. And if we're working on the BMS or other sub-part, then we also have Japanese coming about, right? So a bit of a complex story, but I like the idea that you can pull resources together and maybe stop acting in different silos. I know that some of the colleagues in the room are very much active in this way, so it's a very relevant one. A topic that was on my list, which we didn't really check upon, because, but starting maybe with, I was about to tell you that I said I would challenge you a bit. I remember it was last September. We're active in permanent magnet, neodymium ferron boron magnets, for industry. And I remember a discussion between a recycler and an end user. And the recycler was producing from end-of-life material new magnets, right? And then the recycler tells the end user, well, this is the maximum grade we can have. This is the best cost we can offer. And the end user telling the other guy, well, look, I'm sorry, but I'm turning to China, where I keep sourcing from China because this is not enough graded. This is actually cheaper sourcing from China. The reaction from the recycler was, couldn't you adjust your product design or change your design or your system? It was difficult to. It's a bit difficult, and that's why I was wondering how you saw the end user, but also who to bear the cost. Because I struggle to see where how we can impose that, except what you said, Stephane, with regulation. And I was wondering if you had other elements in mind to stimulate that end user, right? I mean, we've seen some aerospace cases here, where you mentioned also, Bruno, the regulation, regulatory safety, and so on. Some of them, they have the cash, right, to invest, to scale, and so on. But they need to be reassured, so they need validation. They need, a lot of other things. Do you see some of those things, that would be interesting to support, to stimulate the end user in adoption?
Yeah, as long as the end user has the price and the cost as the only and as the one goal, it will be difficult to integrate innovative approach. Obviously, it will cost more. So it may be from the customer. So stop buying products that are not called responsible, maybe labels or things like that. It could be also a will from the industrial to say, okay, I take my part as an entity. I take my part in the change. I feel it's necessary, and but maybe it's a very naive response. but I think we will need to some change in perspective, and money and cost could not still the only criteria of decision if you want to achieve our overall goal, which is sovereignty and environment improvement.
Let me intervene here because, you know, I told you I'm not an engineer, right? Nobody is perfect. But I have a bit of financial background. And so if we say the cost will be the cost, then it means as a company that I need more revenue, right? Somehow. Do you think that the end user, like the customers, can play a role in that? In terms of social acceptance, maybe working on something with the end user side? Well, end user,
it's
final end user.
It's very difficult. It's very difficult for people, for everybody, even me. We have a consciousnness about but when I have to pay something, yeah, it's hard. Okay, so we already feel, everybody feels like that way. But the hope is that the change could be made by a little percentage of the population. So if so there is the theory of the tipping point from Gadwell, where 10% of population could initiate a change and a viral change. So yeah, there is the hope. There is this hope that industrial starts to take their parts, make money because people prefer to buy their product because they are more environmental friendly, made in Europe, etc. And once the first 10% of this industrial manage to make money with this new product, I think it will bring together all the industrial in the same trends.
Bruno?
I think it's a question.
Are you ready to cut corners?
No, I think in this point there's several points in the table. We just said, I think one point it's also about the cultural approach. If we are willing to pay to, because we can, I think all of us that are here that travel through airplane, the companies nowadays ask if you want to contribute to the CO2. And we can ask how many of us say, okay, voluntarily I will pay another euros more to put it there. I think that's a cultural thing that we need to understand, and probably the young generations are more willing to go for this because they are more focused on environmental approach. But I think the main question to pass at least part of the cost to the final end user, it's the added value or the perceptional value that they add of the product. That it's only, okay, I have to pay something because they want to change the batteries. But if you want, and I think now we have the perfect example, unfortunately, that it's with the war and the increase of the fuel, people start to understand, okay, my neighbor have an electric car, and this, even if it was expensive in the beginning, the return of investment, it is going to be quick. And I'm not so, how can I say, so against this, and even if the car takes 1 hour to charge, that's another thing that we are trying to, everyone to tackle. I think the value that they understand, they are more inclined to spend more, even if the cost is passed to them. But it's more a question of marketing and.
Yeah, but that's interesting because somehow what you put forward is that right now we're not competitive because we have an investment gap, because there is a need for end users to move. And then you put forward, the both of you, that this is a long-term change, that this is something that will take time. So there is an urgency to actually invest right now, but the changes that will drive demand are actually happening more today or the day after. That's a bit what I keep from your comments, which is a bit of a bummer for an investor to say, okay, I invest X hundred of millions, and then, well, you know, payback time will be probably 20 years. It's a bit of a challenge. And I was also thinking of the timing part because, well, we were speaking of batteries, and I saw that you were juggling with NMC, LFP chemistries across the project, so that's good. But somehow that's right now. This is what we have on the market now. This is what is flooding in the market. That's okay. But this timing thing also makes me think of this move towards, you know, lithium sulfur, sodium ion, and other chemistries. How do you position towards that? What is your opinion? I mean, by the time we manage to scale towards LFP, NMC, and so on, would it not be too late? Or how do you look at it?
Yeah, so as guys who are working for battery system, so assembly cells and building battery module, battery packs, I would say that the cells chemistry does not really matter we have the methodology to take the benefits from each technology and to lower the drawback. We have the methodology, the tools, and we are able to build performance, for example, for NEMC. One of the issue is the safety, and we have seen that we are able to build a safe pack even with NEMC. So when the new chemistry will come to the market with its benefit and drawbacks, we will adjust our battery system to take the better of its technology. Yeah. So we are dependent on the cell availability, but once the cell are on the market, I'm confident that we will be able to build a performant battery.
Okay, so you don't see pack integration as a challenge. It's
No.
not where it will happen then.
It requires works. It's not done, but we have all the tools to perform this work, I think.
Yeah, I fully agree with the approach. If we are talking about system, it even can get that we are developing a bulletproof thing for the future, that probably solid state cells are going to be safer because you don't have liquid electrolyte to catch fire and to have these thermal runaways. So probably we will even get the different approach that it's to simplify the battery pack. So I think what we are doing right now is preparing us for the future, being these cells or being another chemistry. The only thing that it will get, it's on the safety part. Probably we are bulletproof, let's say, for this future. Yeah. But what probably in the new development, what we'll bring is, I think we can get the costs lower. Not with solid state. I think solid state is your intermediate solution, something for the immediate future. But for the, let's say, medium term, the new ones probably can put us ahead of China or something, because we can get into a part that probably the main materials are not coming from there, and we can rely on that part.
We will be done with all those tragic raw materials and the supply chain disruptions. That's the message. Or cobalt mined in difficult conditions.
Yes.
All right. I think that I've cooked you enough, because you must be hungry by that time. Is there any question from the audience or any comments so far? You're still alive, I see this. So it's already a good sign. But I'm sure you will get a lot of questions and comments. Please give a warm round of applause for our speakers, please. Thank you very much, Stephane, Bruno. And I will hand over now to our colleagues from Lomartov for the next steps. Michaela?
Yes, thank you very much, Pierre, for moderating this very interesting discussion. This was a small one. We have a, let's say, more larger roundtable for after the lunch. We will be inviting you in the same place we had the coffee break, but before that, just a few, let's say, elements to draw your attention. As you have seen also briefly during the coffee break, we are having a graphical designer. We have Blanche with us today that is trying to capture all your discussions into a visual poster of the day that we will very well see at the end of our meeting. You can see before the lunch how it looks so far based on what you have presented and what you have discussed. We will not comment, so if we can share it. We will not comment on it. We will let you simply discover the keywords and the concepts and the points that Blanche extracted from all the discussions so far. And also during the lunch break, you will be able to see, if you will come from time to time in this meeting room, the 3 VERSAPRINT videos that are also available online. But since you are here, and since at some point you will be curious about it, you can also see them projected during the lunch. Now we will go towards the registration desk where you have signed, because we are getting ready for a group picture. And if you appear in the group picture, you qualify for the lunch. And we will be back at 2 o'clock to resume our discussions. Thank you.